All right. Today I want to talk about piecewise defined functions. This is a really interesting thing because it acknowledges that sometimes in a situation it's not just one relationship that is always true, but sometimes depending on where you are in the process, the relationship changes. And so this is the mathematician's way of dealing with those situations where the relationship is not always defined the same way. But we can at least say in this place the relationship looks like this, and then when you move out of that to the next one, then this is how it changes. And so the structure for a piecewise defined function is this thing right here. And what we do is we have those rules for the relationships that tell you how you change the input into the output. And then each one of those actually has a domain. And sometimes they even spell domain correctly. So every one of them has a domain that says this is when you can use this input-output relationship. Remember, domain is about the input, so these domains off to the side are going to tell you when you can use that particular rule. And we can string as many of those together in there as we need to. Normally we don't see a ton of them in there, but it certainly is a possibility. Okay, so let's look at some examples. Here's one where there are 3 different rules depending on where you are. And they're asking us to complete a table for this and then sketch a little graph. Okay. Now it looks like I made that graph really small. I don't know if it's I can make it a little bit bigger. Okay. So to begin with, it says the first x is a -3. So the first thing I have to do is decide where is the domain that will accept a -3. So I'm at -3. This one right here, if I looked at it, this says this rule is only good if your x value is bigger than 2. Well, -3 is not bigger than 2. This one says this rule is only good if your x value is between -1 and 2. Mine is not. Mine is definitely smaller than -1. So the -3, the only place it has to go is into this one. And -3 squared is 9. 9 minus 2 is a 7. Okay. If I go to a -2, -2 also smaller than -1, it doesn't fit into any of these other domains. And so -2 times -2 is 4. 4 minus 2 is a 2. Okay. My next input is a -1. Where does that -1 go? Well, if I am looking at that, my -1, I mean, this references -1 here, but it's a less than. -1 is not less than -1. This rule has a less than or equal to, so this is the one where the -1 goes. And so the -1 goes into the input for that. 2 to the -1 is a half. Okay. 0 is also between -1 and 2. So it goes in here. 2 to the 0 is 1. 1 is between -1 and 2. 2 to the first power is 2. The equal to part is on this one as well. So 2 is between -1 and 2, including 2, which is what the domain was in this piece. So 2 squared is 4. And the 3, however, okay, if I take a look at that, 3 is, 3 is bigger than 2, so this is the rule that applies, so I get a 6 minus 3, which is a 3. So let's plot some points here and see if we can figure out what this graph is going to look like. So I got a -3, 7, okay, and a -2, 2. And this is a parabola, so I know there's some kind of curve to that. If I wanted to nail that curve down a little bit more, I would have to figure that out. I think it probably starts down here, and as my parabola, actually it's a parabola shifted down to, so the vertex is going to be down here somewhere, but these points over there are not part of it. It will get very close to where it was at -1, and I could actually, at -1, I'm going to get -1 out of this, so it's going to kind of start there and do a side of a parabola off this direction. 2 to the -1 is 1/2, so this is the actual point at -1. 0 is a 1, and I've got a 1, 2 and a 2, 4, so that's part of my exponential function going and growing that direction at those points. And then I've got the point 3, 3 from the other one. So 3, 3 is right here. If I wanted to know what was going on between 2 and 3, I could plug the 2 into this equation as long as I know that that's just an open circle there. 6 minus 2 is 4. So 2, 4 actually opens right up there. This is a linear equation that goes off this direction. And those actually join at that point. So 2, 4 is on this because it's on the middle rule. It just happens to also be on the bottom rule. So there is a graph of the piecewise defined function and a table to help us make that along the way. I don't know that there's a real situation where that is how things behave, but we mixed several of our different parent functions in there and said it's different functions in different places, and we need both of those pieces of information. Okay. Here's just a simple way of asking this question. Find g of 3 if g of x is equal to this. Okay. Well, if g of x is equal to that, and we want g of 3, that means we want the input to be 3. And so we got to bring our input over here and decide where is this 3 going. Okay. Well, 3 is greater than or equal to 3. It doesn't fit in this one, so the 3 is not going into the logarithm function. The 3 is going into this one. So we would say g of 3 for this is 2 over 10 to the third, which as a decimal is like 0.002. Right, scientific notation is 2 times 10 to the -3. I want to think of it that way, or 2 1,000ths. All right. Finally, here's his story. Go along with this. The cost to mail an envelope through the mail is 55 cents for any envelope that weighs 2 ounces or less. And for letters that weigh more than 2 ounces, the cost goes up by 10 cents per ounce. Sketch a graph and write a piecewise defined function to represent the situation. Okay. Well, there's an easy implied domain here. Okay. At least the bottom end of the domain, because we can't try to mail something that weighs 0. Okay. So our domain, the graph definitely starts here at 0, and it theoretically could continue going, although we can't mail an infinitely heavy thing along the way, so this won't go forever, and at some point the post office will probably say nobody here can lift that thing, nor can any of our trucks, so we can't mail that for you. Okay, I'm going to put a little break in this axis because nothing is happening until I hit 55 cents. Okay, and so I'll call this line right here 55 cents. And then we will go up by, we'll make every 2 marks 10 cents. So this will be 65, and this will be 75, etc. And let's make some marks along this axis. I'll go every 3, I'll say is 1, just so it spreads it out a little bit. So that blob there is a 1. So this is ounces down here, and this is dollars on this part. And so for the first 2 ounces, I can get for 55 cents. Okay. But then when I hit 3 ounces, it's now going to be 65 cents. And when I hit 4 ounces, it's going to be 75 cents. So I can see from here it turns and it goes off this direction. If I could draw a straight line, it would be amazing. Okay. All right, so what is the equation for this thing? Well, my f of x, I'll just go ahead and use f. It looks like there are 2 different rules that are in play here. I can kind of see the number of parts that are there and recognize I only need 2 rules. The first one's just a horizontal line. That's a constant. So that rule is whatever the input is, just make it 55 cents. Okay? But that is only true for your x values that are between 0 and 2. Okay, the 2 ouncer will go for that amount. I'm not going to put a less than or equal to pointing at that 0 because hopefully I'm not going in trying to mail something that weighs 0 ounces. So they're not going to charge me 55 cents to mail nothing. Okay? Nor should I be trying to mail nothing. All right, let's take a look at our other. We've got a linear equation here, and it looks like if we were talking about slopes, we've got a rise of 0.1, and we've got a run. I made my run too far. The run is right here. So for every run of 1, there's a rise of 0.1. So this has a slope of 0.1. And so using my y minus y1 formula, I can say y minus y1 is equal to 0.1 times x minus x1. And I need to just pick a point. I can pick this point. This is the point 2, 0.55. So when the x is 2, the y, or I can just put those points in, the x1 as 2 and the y as 0.55. So y minus 55 cents is equal to 0.1 times x minus 2. And so y minus 0.55 is equal to 0.1x minus 0.2. And if I add the 0.55 to both sides, then it's going to say my equation is 0.1x plus 0.35. And that should be my rule for the green part of the line. So the rule is 0.1x plus 0.35, and that will apply for x's that are bigger than 2. I don't know where the top end of that is going to be, but this is what that equation should look like, that piecewise defined equation. Again, I could visually see 2 parts, so I have 2 rules and a domain for each of those rules.